Assalamualaikum and hi everyone. My name is Abu Zahir bin Ahmad. So basically today I'm going to explain about my final year project with entitled Determination of BPA in river water samples by using MIP SPE followed by HPLC. So my supervisor is Dr. Tuan Muhammad Fauzan bin Tuan Omar and my co-supervisor is Dr. Azrilawani binti Ahmad. So let's go start. As we know that bisphenol A, or known as BPA, is one of the endocrine disruptor compound or EDC that widely found in the environment due to the various industrial discharge. Global production of this synthetic chemical is estimated around 3 million tons and it is expected to increase in the future due to increasing demand. BPA also widely used in the manufacturing of polycarbonate plastics and epoxy resins. According to the World Health Organization (WHO), the endocrine system regulates the metabolism and function of the body. Endocrine glands secrete hormones that act on their target organ through receptor. However, with the presence of endocrine disruptor compound (EDC), it will change the signal of hormone in the body tissues. The significance of this study is to understand the ability of molecular imprinted polymer MIP to remove the BPA from the water samples with combination of solid phase extraction technique. Move to the objective. Okay, the objective of this research actually is to synthesize specific molecular imprinted polymer for BPA. Second, to extract the BPA from water samples by using MIP SPE. And third, to characterize the specific molecular imprinted polymer using SEM, TGA, BET, and FTIR. So next is methodology. So for methodology, the first thing first is preparation of molecular imprinted polymer. In order to prepare the molecular imprinted polymer, there's 5 things that we need to consider. First is template, monomer, initiator, crosslinker, and solvent. So for this research, I have been using BPA as a template, MAA as a monomer, azobase as an initiator, EGDMA as a crosslinker, and acetonitrile as a solvent. So here's a few steps that we need to use in order to synthesize MIP. First, mix together all the template, initiator, monomer, crosslinker, and solvent in a test tube. After mix well, do a nitrogen purge for 10 minutes. After nitrogen purge is done, put it on water bath with 60 degrees Celsius and make sure the temperature on the mental heater is above 60 degrees Celsius, maybe around 92 degrees Celsius. So after that, let it on water bath for 24 hours. After 24 hours, cool it first in room temperature. After the polymer is obtained, the polymer will be crushed and grind for 25 minutes with speed at high RPM, and lastly, it will sieve. So next is Soxhlet process. The purpose of Soxhlet process actually is to remove the template, which is BPA, in the polymer by using methanol and acetic acid with ratio 9:1 at 250 ml for 8 hours. And after that, MIP is ready to use. After the MIP is fully synthesized, the next step is MIP SPE, where the molecular imprinted polymer is ready to use and work as an absorbent in the solid phase extraction technique. The MIP will pack into empty SPE cartridge, and the top and bottom of cartridges is protected by the wool. Next is solid phase extraction technique. So here's a few steps for sample extraction. First, transfer 100 ml of filtered sample into the conical flask. Second, add 100 mg of sodium EDTA 2 hours before the extraction. Third, solid phase extraction is start. After that, the extract sample will concentrate with rotary evaporator. Then the extract will drying under gentle stream of nitrogen gas. After that, the extract will undergo final reconstitution with H2O and acetonitrile with ratio 70 and 30. And finally, the extract samples is ready for HPLC analysis. This is the result of molecular imprinted polymer under the scanning electron microscopic instrument, and it shows the morphology structure of molecular imprinted polymer after Soxhlet is less rough compared to the molecular imprinted before Soxhlet. This proves the Soxhlet process is successful in removing the template, which is BPA. That's all from me. Thank you.